So hello guys, good morning. We are once again picking up a grade 12 math lesson for the topic trigonometry. Yeah, we are back and we are very much excited to be here. I guess for the video purpose, I'll go ahead and start the lesson. Those who join us will join us as we go along. It is 16 minutes past 5, so I think it stands without reason that I would definitely just go ahead and we'll start the lesson for the grade 12s. Okay, so we've been busy with trigonometry, and for those who are joining in, maybe let's say you're joining in for the first time, I hold live lesson sessions in the morning for grade 12s, and basically we've been busy with trigonometry. So I've done double angles, compound angles. We've looked at types of problems that have to do with compound angles and double angles, how to simplify, how to expand, and basically how to use those various types of double and compound angle identities to be able to reduce or to expand or to simplify whatever the question may be. Also, we have been yesterday we did Pythagoras type questions where we're supposed to draw a right angle triangle in a particular quadrant using information that has been given to us. So it is my hope that those who may be joining in, who maybe are like, I'm seeing this for the first time, you guys should go to my link, my bio. There's a link in my bio that basically exposes you to the YouTube channel that I have, where I upload the lessons that I've done. So the past 3 or 4 lessons that I've done this week are already in the they are uploaded on the YouTube channel for you to watch and rewatch at your own time and pace. So you guys can go to my link in my bio, my YouTube link. You can obviously join, subscribe, and then you can actually follow up on every lesson that I've done to this point, so that you can be able to get the required assistance that you need. Do I do private lessons? Due to my time constraints, I guess a lot of times people don't believe, but I have a very tough time doing private lessons at the moment because of my time constraints. I'm constantly busy because I am an educator myself at a school, and I am teaching a grade 12 class this year. So I tend to be extremely busy, so time for private lessons are very difficult for me. Let me just put it that way. So I tend to not really have time for that. So I can only do, these live lessons, but maybe in the future I'll be able to avail myself for such. All right. So I guess it's only a matter of time. We'll see as time goes by, but for now, private lessons are not a viable option for me, given my time constraints. So hopefully that answers that question. And I hope that brings clarity to you insofar as what you were asking. So I think without any further ado, let us look at simplification problems today, together with identities, okay? Because that's where we need to go to next. We have done a myriad of problems that basically have to do with other things. Now I think we can go ahead and look at some simplification questions. In conjunction with those simplification questions, we can also look at numerical type simplification questions, and also we can look at identities as well. So hopefully today we can actually go ahead and do that, so that we can also become a bit more familiar with those kinds of questions, because yesterday obviously we did Pythagoras type, and that Pythagoras type was, I think, covered quite thoroughly, I believe. But so those who have missed out, like I said, please do check out my YouTube channel. That's there where you can check out the live lessons that I've done to this point. Okay. Sorry, I just need to set up a little bit here. Just hang on, guys. Okay, sorry about that. Okay. Yeah, so interesting thing, yesterday someone actually sent me a question, and this was a grade 11 learner, grade 12 learner, and they sent me this question, which I thought was quite interesting. I thought it was a very interesting question, and I'm just going to start off on that question. The question said simplify, and it said 1 minus, I think it was 1 minus 4 sine squared theta, I believe, yes. So the learner sent me this, and they were like, sir, I need help with this question. I don't know how to answer it. And at the time, I was extremely busy when they sent me the question, so I couldn't really attend to it. And then eventually, I was able to sit down and look at the question, and then just sort of like check what viable approach I could actually take in being able to answer the question. I want you guys to know that I by no means claim to know everything. I don't. Sometimes it takes me a bit of time to look at a problem and to actually like see, oh, okay, this is what I'm supposed, or this is what I ought to do. Okay. So I looked at it and I was like, okay, seems like for me there's a couple of options, or a couple of viable options that I can take. So when I looked at this 4 sine squared theta, for instance, the first time when I looked at it, I was like, maybe if I look at my strategy approach, because remember I told you guys that your strategies that you employ whenever you are given a simplification question is, you need to look first at 1, can you simplify anything? Meaning, in other words, if you look at the expression, are there any like terms? Can you add or subtract any like terms? Is there maybe some algebraic manipulation you can apply here of any sort, right? Because you need to look at it in that light. But if not, then you can look at your second option, factorization. Can you perhaps factorize this question or this expression? If not, then you need to look at your identities. And by identities, you look at your square identity from grade 11. You're looking at your quotient identity from grade 11 as well, or you're looking at your double angles or compound angles identities. Okay, so when I look at this, I'm like 1 minus 4 sine squared theta. Okay, so the strategy that I kind of see that I can apply here, all right, immediately, is if I look at simplification. Okay, I'm like, okay, maybe not simplification. If I look at 2, factorization, okay, the thing is, this is kind of giving me those double angle vibes, you know. Your double angle expression for cos 2 theta, there are 3 viable options for cos 2 theta. There's the 2 cos squared theta minus 1. This was not, I think the question was not theta, it was 1 minus 4. Sorry, guys. Sine squared 15. Yes, it was 15 degrees. You see, now I'm actually writing the question of this learner incorrectly. So this was how it was. 4 sine squared 15. So I remember when I looked at the 15, I was like, if only there was like a double angle of some sort that we could use, then basically this 15 would become 30 degrees, and then that 30 degrees would be a special angle and we'd be able to move from there. So that's what came to my mind immediately when I saw this question. And I guess my thoughts then led me to actually conclude that there's something I need to do that should lead me to a double angle. Okay. The only reason why that is the case is because the more familiar you become with problems and the more you do problems, you kind of like quickly develop sort of like mental strategies on how to approach certain things, and you can make connections with certain things. So I looked at this and I was like, 4 sine squared 15. Okay, it's giving me that double angle, sort of like the 1 minus 2 sine squared 1 minus 2 sine squared 15. Okay, but I don't have that. So what I did, okay, was I looked at this and I was like, okay, let's take out a common factor 2. Now the thing is, you look at the 1 and you're like, but 1 is not 1 is 1. So how in the world do you then decide to take out a common factor of 2? So here's the thing. If I take out 2, then the 1 is actually going to be half. Because remember, 2 times a half gives me 1. Then minus, look at this, 4 sine squared theta, this becomes 2 sine squared 15 degrees. Okay, so I started right there. Now, you see, 2 times half gives me back the 1. 2 times negative 2 gives me back the negative 4 sine squared 15. Okay, so this is a factorization strategy that I applied. Okay, so I applied factorization. Okay, then I go to number 3. Any identity? No. Okay, this is kind of close. Okay, any identity? Okay, so basically, if I can do the following, and I want you guys to pay close attention to what I'm about to do. Minus 2 sine squared 15. Now, look at what I do. I'm going to say plus 1 minus 1. Plus 1 minus 1. What's plus 1 minus 1, guys? Doesn't that give me 0? Okay, it does. Now the thing is, here I have just applied a strategy that we call the additive inverse. It's a simplification strategy, the additive inverse. The thing is, I know that there's a double angle expression that I want to basically be able to utilize, because I can see this is 15 degrees. If I can use the double angle, I can reduce this to a double angle. That would be really nice. Okay, that would actually help me out a lot. But remember, here after the sine squared, 2 sine squared 15 degrees, it's like you have a term that is plus 0 or minus 0. Now 0, how do I form 0? I can say plus 1 minus 1. This is all in preparation for me actually utilizing this expression, which is basically, I know, if you remember, guys, cos of 2a can be one of 3 things. You can say cos squared a minus sine squared a, or it can be 2 cos squared a minus 1, or it can be 1 minus 2 sine squared a. These are the 3 of the forms of the expansion of the double angle of cos. Okay, this is from grade 12. Double angle of cos can either be cos squared a minus sine squared a, 2 cos squared a minus 1, or 1 minus 2 sine squared a. So appropriately here, that's what I've done. I used the additive inverse so that I can set up this here. This here is actually equal to what? 1 minus 2 sine squared a. Remember, this is positive 1. This is negative 2 sine squared 15. So this here is my double angle. And I hope you guys can see that. So you have half minus here. Okay, 1. This is positive 1. This is minus 2 sine squared 15. This can be written as cos to 15 degrees. And remember this negative 1, it is still there, didn't go anywhere. Okay, so I put the bracket around, there's the 2 outside, that hasn't gone anywhere. Okay, so I used my additive inverse here for 2 sine squared 15 plus 1. I used the additive inverse so that I can be able to set up a double angle expression so that I can write the reduced form of the double angle for 2 sine squared 15, negative 2 sine squared 15 plus 1, which gives me negative cos 2 15. In fact, like I said, it's not negative, it has to be plus cos 215. Because remember, this entire, in fact, this whole entire thing, this is 1 minus 2 sine squared 15, and this can be replaced by what? A positive cos 2a. In other words, a positive, what's the a angle? It is 15 degrees. A positive cos 15 degrees. So it has to be positive. Because remember, this entire thing, minus 2 sine squared 15 plus 1. Remember, minus 2 sine squared 15 plus 1 is like saying 1, because the 1 is positive, minus 2 sine squared 15 degrees. So this is the same thing, because addition is commutative. So I can rewrite this. 1 was positive, it's still positive. 2 sine squared 15 was negative. This is this expression, and it actually can be reduced to become cos 2a. A is in this case the 15 degrees, so 2 times 15. Okay, so let's continue. Then we have 2 into, that's half. Then the plus cos 2 times 15 is 30 degrees minus 1. Now you can actually take this, what we have here, and you can utilize your calculator to actually then express the cos 30 as a actual numerical expression or a numerical value. So 2 into the half plus, what's cos 30, guys? Does anyone have their calculator? And can they tell me what cos 30 is? Okay, that's root 3 over 2. At least that's what I can remember. Okay, then what I'll do is I'll just take the 2 and distribute it inside. Okay, so 2 into half, that gives me 1, plus 2 into root 3 over 2, that gives me root 3, and then 2 times negative 1, that gives me negative 2. Then I can add the like terms here. 1 minus 2, I have root 3. 1 minus 2 gives me negative 1. So that's basically my answer. Okay. So yeah, I thought this was a pretty nice question. At first, it kind of looks like it could be simple. But of course, then you can see that, oh, okay, it needs a little bit more work. And it needs some out-of-the-box thinking. Because it's not really as straightforward, or it is not as forthcoming as one would think it ought or it is. Okay, so yeah, I actually really thought that was a nice question that one can actually get or be asked at a certain particular time. Okay, all right, so let me just get on now with what I had actually planned on doing today. I just thought, let me just get that introduction problem out of the way, because that was a question that a particular learner had asked. Okay, so we're going to look at some simplification questions here, and hopefully also we can check out some identities. So that's what I'm planning to do today: simplification and identities. Let's get that going and get that rolling and get that flowing. Okay, guys, let's say we are given the following problem: sine of 180 minus alpha cos of 360 minus beta plus cos of 180 plus alpha, and we are given cos of 360 minus beta. So here at this particular simplification question, we are asked sine of 180 minus alpha times cos of 360 minus beta plus cos of 180 plus alpha and cos of 360 minus beta. So the strategy that we still apply is still the same. 1, 2, 3. We first check, is there any simplification that we can do? Remember guys, with the simplification, we look, is there any, like when we look at bad maths, as in like brackets, exponents, division, multiplication, addition, and subtraction. Okay, if we look at this, is there any addition, brackets, exponents that we need to apply, division, maybe multiplication of anything, addition or subtraction of like terms, if there's any addition and subtraction of like terms, and so forth. That's all simplification. Also, remember, in grade 11, you guys learned about reduction. Okay, using function values and using co-ratios. Okay, negative angles, angles greater than 360, all of that. So that all falls under simplification. So now here, when we look at this, okay, sine of 180 minus alpha, it's multiplied by cos of 360 minus beta plus cos of 180 plus alpha times cos of 360 minus beta. This is a multiplication relationship plus another multiplication relationship, but we can clearly see that here we can reduce, okay, using our function values. So 180 minus is a function value. So what we say is 180 minus, in which quadrant is 180 minus? Okay, so you guys, I'm sure, can still remember the whole cast diagram. The fact that we have CAST, that here in this quadrant, we know that this quadrant, the S quadrant, we have 180 minus, here we have 180 plus, here we have 360 minus. And all of these, 180 minus, 180 plus, 360 minus, these are what we call function values, all right? And we always ask ourselves, 180 minus is in which quadrant? It's in the second quadrant. And we look at this quadrant, only sine is positive, but all the other trig ratios, tan, cos, are negative. Here, 180 plus, only tan is positive. Sine and cos are negative. In this quadrant, 360 minus quadrant, the fourth quadrant, only cos is positive. All the other trig ratios, sine and tan, are negative. So when we look at this, 180 minus alpha, I'm first going to just expose you to how we do it as per the quadrant, and then I'm going to just tell you how to do it simply without actually really thinking about it using your calculator. So what we would do is we would reduce all of this, and this is the simplification that we apply. So we are applying simplification and we are reducing the function values. 180 minus is in which quadrant? It is in the second quadrant. How is this trig ratio in that quadrant? Sine is what? Is it positive or negative in that quadrant? So we know that sine is positive. So that's why I've not written a negative before the sign. I've written a positive. And then 180 minus. The 180 minus falls away. We then write the acute angle alpha. And I would suggest that you put this in brackets the minute you reduce it. Okay? Then we move on to the next function value, cos of 360 minus. Remember, this dot stands for multiply. So by putting it in brackets, you also just further emphasize this multiplication relationship that exists between sine and cos. So 360 minus beta is in which quadrant, guys? So 360 minus is in the fourth quadrant. How is cos in that fourth quadrant? Cos is also positive. So in brackets again, you write cos of, not alpha, the letter there or the angle is beta. Okay, so yes, cos of beta, and it's positive. Another bracket, which is sweet. Then you follow it up with this plus sign. So we write the plus sign, and then we go and evaluate this trig ratio. 180 plus is in which quadrant? 180 plus is in the third quadrant. How is cos in that quadrant? Cos is negative because only tan is positive in the third quadrant. So then you write negative in brackets. You remember there was a plus sign there. You write negative in brackets cos of the angle alpha. Okay. Then the last and final bracket, cos of 360 minus beta. Cos of 360 minus beta, minus 360 minus is in the fourth quadrant. How is cos in that quadrant? Cos is positive. So then we write in brackets cos of alpha. Let me now reveal to you that every time, guys, you do this correctly, this reduction, there is a mark that is attached to the correct trig ratio together with its sign. So we need to make sure that we get this 100% correct. Please, please, please. Now the reduction simplification is finished. Okay, so we've simplified, we've reduced all of the 1, 2, 3, 4 trig ratios. The next thing now we need to sort out is still under simplification. We need to check if the signs are 100% correct. So we have this here, sine alpha and cos beta, that's one term, plus separates the second term, negative cos alpha and cos, okay, sorry guys, I did a mistake there. You see that it's beta there, but I wrote alpha. That's not good. I'm supposed to write what? Beta. Okay, so that was a mistake that I made. Okay, please, yeah, I mustn't get carried away. I must be vigilant of the angle that I'm talking about here. So when I reduce, the acute angle is beta. Here, oh sorry, the acute angle, sorry, was alpha for the first one. Okay, so once again, it's me. Sorry guys. That is alpha followed by what? By beta. So that's me. It's all on me. Okay. So guys, if I make the error, you learn from it, you don't do it. Okay. If I do it, I do it, but you don't do it. You don't repeat my errors. Okay. So that was supposed to be alpha for the first one, followed by beta, which is the second one. So that's fine. Hope you guys now see it. Then, like I was saying to you now, the signs, this is sine alpha and cos beta. These are both positive. So this still remains as sine alpha cos beta. Can fully remove the bracket because the positive times the positive gives me a positive sine alpha cos beta. Let's look at this one. Positive times a negative times another positive. What's positive times a negative? That is negative. Then a negative times a positive still gives me a negative. So my middle sign is no longer positive, but it is negative. Then now I can write cos of alpha followed by cos of I wrote down the question incorrectly, guys. Do you see this? Okay, let's just write anyways. Cos beta. Look at me making so many mistakes and errors. Okay, yeah. Right. So with this particular question, I would end right there because I'm sure you guys can see this here. Have breakfast, don't kill me here. Okay, so sine alpha cos beta, you see, and minus cos alpha cos beta. So in other words, this here does not mirror my what? My compound angle at all, because this is sine cos, this is cos cos. So this does not mirror my compound angle identity at all. So I would leave it like this. Okay, so let's do another one. Okay. It's fine, even if yeah. All right, let's do another one. Sine of 90 minus a into cos of negative b plus sine of negative a times cos of 90 minus b. This is grade 12, guys, grade 12. Okay, let's look at this one. So sine of 90 minus a times cos of negative b plus sine of negative a times cos of 90 minus b. So once again, we look at this. We have a product of two trig ratios, plus will separate the product of the other trig ratios. So all in all, if I was to ask you how many terms do we have 1, 2. So now simplification strategy we will apply is we are going to reduce the function values and the co-function values. So let's look at this one, sine 90 minus a. Now please guys, always take note that 90 is that trig ratio that will change sine to become cos. So this is actually cos, and then 90 minus a, 90 minus, okay, so that's our co-ratios. Co-ratios and your 90 minus quadrant, this is in the first quadrant, 90 plus, 270 minus, and 270 plus. These are what we call our co-ratios. And for co-ratios, sine will change to cos, and cos will change to sine, vice versa. So obviously when we say 90 minus, we are talking about the first quadrant. In the first quadrant, we know that all trig ratios are positive. So if we evaluate sine of 90 minus a, 90 minus is in the first quadrant, but because it is a co-ratio, our sine changes to cos, and then we assume the acute angle. That's a mark. We put it in brackets. Cos of negative b. Now, that's a negative angle. Okay. Our strategy for negative angles is very simple. What we do is we simply add 360 for negative angles. Okay. We add 360. Okay. When we add 360, this becomes 360 minus b. Now, 360 minus b is in the fourth quadrant. So if you are going to evaluate 360 minus b in the fourth quadrant, how is cos? Cos is actually positive. So I'm going to write cos of b, okay, in brackets. Then I follow it up with, now I need to evaluate these ones, okay? Yes, Lisakanya. Yes, Lisakanya. When it is x minus 90, it will also change. Remember, x minus 90, Lisakanya, if it was, let's say, cos of x minus 90, what you would do is you would also regard this as a function value. Okay, it would also change. Now, with the grade 11s, we always tell them that if you want to reduce cos of x minus 90, all you do is you first, this is a negative angle first and foremost, so you will add 360 first and foremost. All right. Addition of 360 will mean that you're going to have cos of what? You are going to have cos of 270 degrees plus x. Okay. And then when you have cos of 270 degrees plus x, remember, what did I say? I say co-ratios are 90 minus 90 plus, 270 minus, and 270 plus. So then obviously you would reduce this and you would write it as, now 270 plus is in which quadrant? It's in the fourth quadrant. How is cos there? It is positive. So your answer would be cos of x. So yes, the change from sine to cos and cos to sine only happens with the co-ratios. So the co-ratios, like I said to you guys, are 90 minus, 90 plus, 270 minus, and 270 plus. Okay, so let's not forget that. But with your 180 minus, 180 plus, and 360 minus, there is never a change in the trigonometric ratio. Okay, I hope that makes sense. On Tatile, that will only be later on. All right, probably next week sometime. At the moment, like I said, I'm still getting off the blocks with the compound and double angles, and we're just getting familiar with how to actually work on those, also applying our grade 11 knowledge. So yeah, I don't think even in this week, it will probably be next week sometime. Okay, so cos of A, like I said, you reduce this becomes cos of A, we reduce that, this becomes cos of B. But when we move on here, sine of negative angle A, so once again we have a negative angle. So what do? We add 360. The addition of 360 makes it such that we have now a function value of 360 minus A. That's in the fourth quadrant. How is sine in the fourth quadrant, guys? Sine in the fourth quadrant is negative. So the answer is negative sine of A. Then cos of 90 minus B. Oh, here's another what? Co-ratio. Okay, so this is where sine changes to cos and cos changes to sine. So our cos becomes sine of b. Because 90 minus is in the first quadrant, how is cos? Cos is positive. So then we write the co-ratio, the angle that's acute, which is angle B. Okay, once we are done with that, okay, remember this is all marks. 1, 2, 3, 4 marks in the bag so far because I've reduced 100% correctly. Then the next step is I need to make sure that there is one sign on the left. This is positive already, all of it, so that's fine. There's no problems there. This is cos A, cos B. That's me removing the bracket because positive times a positive is positive. So cos A times cos B, followed by a positive times a negative times a positive. A positive times a negative is negative. Times another positive, it's still what? Negative. So this is negative sine A sine B. Okay? Yeah. So remember, cos, sine, you go to your formula sheet if you've forgotten your compound angles and double angle expressions. But this here, guys, what is it actually equal to? Cos, sine. This is your compound angle for cos, guys. And AB is really the appropriate angle formation. So this is cos of what? A. Remember, the sign changes, plus B. You can go to your formula sheet and read this so that you can get the answer. So that is the answer. The answer is cos of A plus B. Done. Okay, let's look at another one. So it's very important that that knowledge of grade 11 of reduction needs to be on point. Another simple way of making sure that your signs inside the bracket are 100% correct, guys, you can use your calculator here. Okay, the shortcut method is that to ensure that you get the right sign, you can just substitute in the place of A the value of 1. Okay, just substitute 1 here and then put in your calculator sine of 90 minus 1. So that is going to be sine of 89. When you say sine of 89, you are going to get a positive answer. Okay, you're going to get a positive value on your calculator, which means cos is supposed to be positive. Okay, you do the same thing here. Cos of negative, you substitute in the place of B, 1. And you're going to see, you're going to get a positive answer. You're going to get a numerical value, but it's positive. So that means that the sign of cos is positive. You do the same thing. Sine of negative, in the place of A, you substitute 1. You say sine of negative 1, you're going to get a negative answer. So that would mean the trig ratio is also negative. And then cos of 90 minus B, you substitute 1 in the place of B. In your calculator very quickly, you'll get a positive answer, which would mean really and truly the trig ratio is supposed to be positive. So this is another way of making sure that you get your answers being the right sign. But remember, guys, don't forget about the co-ratio. The trig ratio changes, please. And also for your negative angles, addition of 360. But even if you don't know about the addition of 360 with your negative angles, as long as you are substituting 1, you will always know the sign. Because obviously for your function values and your negative angles and your angles greater than 360, if it all reduces to a function value, the trig ratio obviously doesn't change for those ones. Okay, so let's go to another one, number 3. Cos of 450 degrees minus x, cos of 360 minus x, plus sine of negative x into cos of 180 minus x. So guys, don't take for granted, hey, these marks, these ones, can you imagine just being able to get all of these marks, 1, 2, 3, 4, and then all the rest, simplification, the answer. But at least, guys, I mean, if you're gonna be reducing correctly, you're going to be getting the marks nicely. So let's look at this one. We have cos of 450 degrees minus x. This here, all right, we need to see this is an angle greater than 360. So what we first do is we are going to actually subtract 360, because that's what we do to angles that are greater than 360. We subtract 360. So when we subtract 360, what happens? This becomes what? So I'm going to rewrite it. This is actually cos of 90 degrees minus x. Now I know this is the co-function, co-ratio. Okay, I see it for what it is because what did I do? For angles greater than 360, you quickly in your calculator, you subtract 360, you check, oh, what type of angle is it between 0 and 360, because you want to actually put it in that 0 to 360 interval. So that's why we subtract 360. So it's cos 90 minus x. Okay, this one is fine. It's in the interval. Okay, plus this one, obviously, negative angle. So what do we do to negative angles? We add 360, right? That's also now in the quadrant. And then cos of 180 minus x. Sorry guys, this one is interfering with what I had written as notes on the side, but I hope you guys can see this very clearly, right? Okay, now I can reduce because they are now prepared to be reduced. So let's go. 90 minus is in the first quadrant, but in the first quadrant, trig ratio, the function value is a co-ratio. So cos will do what? It will change to sine. So I have sine x. Put in brackets. Cos of 360 minus x. Which quadrant? Fourth quadrant. How is cos there? Cos is also positive. So I write cos x. Plus. Then let's evaluate this and put it in brackets. 360 minus is in the fourth quadrant. How is sine there? Sine is negative. Yo, how many marks so far? 1, 2, 3 marks. Okay, 4. Guys, the marks I'm just collecting. Cos 180 minus x. 180 minus is in the second quadrant. How is cos? Cos is also negative. You see? Yeah, I hope you guys can see very nicely what's happening here. So now the answer is, now I'm going to multiply these two, positive times a positive. Obviously, this is sine x cos x. The bracket can be removed. Then here, positive times a negative is negative. Then a negative times another negative gives you a positive, guys. So I have positive sine x cos x. Do you see this, guys? Do you see it? Hey, I hope you do. Now a few things here. Sine x cos x plus sine x cos x is actually equal to 2 sine x cos x. Okay. Maybe someone else who's answering this question may have not seen this as 2 sine x cos x, because these are like terms, guys. Sine x cos x plus another sine x cos x means there are 2 what? Sine x cos x, which basically means that this is actually the double angle. If I go to my formula sheet, 2 sine x cos x is just basically the double angle of sine 2x. Maybe someone else would have seen it a bit differently. They would have looked at this and been like, okay, sine x cos x, that means that is sine of the x plus x, because they see the compound angle. All right, this is just another way of looking at this. They see the compound angle, because this is sine x cos x, they see the compound angle, sine of x plus x. And then obviously what's x plus x inside the brackets? It's sine of 2x. Okay, one could do it this way, or they could do it that way. Either or, we still arrive at the same answer, and that's all that matters. Okay. Okay. Guys, I hope you are seeing there's nothing too shabby here. Nothing too shabby. Okay, not too shabby at all. Hey, yeah, you prefer compound angles. All right, T-man, no problem. But like I said, you see, someone will see like terms, he will add them, and then oh, they see this is the double angle. Someone else will be like, oh, I see the compound angle. Then they will add the two variables because they are the same. I mean, this is x and x, this is x and x, so that means obviously, you know, it's not different. So you add the like terms, you get sine 2x. Okay, that's simplification at its best. Okay, let's look at this one, and then yeah, after this one I'll move from these types of questions. I think you guys get the point. Cos of 90 degrees minus x times sine of negative x negative 180 degrees plus cos of 180 degrees minus x into cos 1080 degrees plus x. Yeah, now this is a bit drawn out here. Okay, cos of 90 minus x. So here we can see there's a cofunction value. Okay, so before I actually go on and reduce, let's first make sure that everyone is fine. So cos 90 minus x, we are fine here. He's fine, no problem. This here, sine of negative x minus 180 degrees. So this angle is negative. So what do? I add 360 to negative 180. When I add 360, when I use my calculator and add 360, I can see this is actually sine of, remember, 360 minus 180 is actually 180 degrees. This becomes 180 degrees. This x is still negative x. So now I'm actually within the interval of 0 to 360, and that's what I wanted. So for negative angles, we just add 360, guys. We use your calculator. Okay, you add 360 until you can get this angle to be within the 0 to 360 interval, so that you can work with a function value that you know within the 0 and 360 interval. Okay, plus this cos is fine. It's 180 degrees minus x. There's no issues there. But look at this one. 1080. Now someone needs to please, in their calculator, take 1080. This is an angle greater than 360. So what you need to do is we need to subtract. Here we need to subtract 360. And we need to subtract it multiple times until we can get into the interval of 0 to 360. So I need someone to actually subtract T-Man Express. If that's the method that you feel most appropriate in doing, then you can do it. But it's just that for me, that's not the method that I use. So if some of you have found like you've been using a certain method consistently, please don't deviate, because you are used to that method, right? So if you use that method, that's fine. It's just that for me, I find it easier to add 360 to negative angles and to subtract 360 when angles are greater than 360, okay? Until I get into that interval of 0 to 360. Then I evaluate that trig ratio, okay? T-Man Express, if you still get the same answer, you're going to see your next step. Your next step should be the same as mine if you use your method. That the method doesn't really matter, unless, as long as the method works for you and you've been consistently using it, and it's second nature, because it will lead to you actually getting the answer quickly. So guys, I want to ask you, if we subtract 360 the first time, the second time, the third time, the first time, do we get into the interval of 0 to 360? No. So we subtract again 360. Okay, I want someone to tell me, okay, what is the value that actually helps us when we subtract 360? I want someone to tell me the value that we'll eventually get that was going to be within the 0 to 360 interval. So we subtract 360 the first time, what do we get? We're still greater than 360. Then we need to subtract the second time. What do we get? Okay, so we still get 360 plus x, but still we need to subtract again. So after subtracting again, we get 0. Okay, we subtract until I think there's a point where you get 0, I believe. Yeah, you get 0. Because when you subtract 360 the third time, you get 0 plus x. And that's fine, because 0 plus x, that simply means that this is actually cos x. And that's it. Okay, so here, the evaluation has already been done. Okay, yeah. Okay, so now we can evaluate these. Okay, now 90 minus is in which quadrant? First, how is cos? Cos is positive, so we change it to the trig ratio sine of x in brackets. Sine of 180 minus x, 180 minus is in the second quadrant. How is sine? Sine is positive. So we say sine of x. Then we move on here, plus, we write the plus. Then in brackets, 180 minus which quadrant? 180 minus is in the second quadrant. How is cos? Cos is negative. And then last but not least, this is cos of x, obviously. Okay, because we've already gotten the evaluation after subtracting 360 multiple times. We eventually get 0, so that just means this is cos x. Now we can go ahead and look at sine x times sine x. Sine x times sine x is sine squared x. Then positive times a negative. What's positive times a negative, guys? Positive times a negative is a negative. And the negative times a positive is still a negative. So we have negative cos squared x, because cos times cos is cos squared x. Now when we look at this, we are like, okay, this is not the identity from grade 11 that gives us 1. No. This kind of has that sort of like look of the double angle for cos. But if cos squared x was first followed by sine squared x and the negative sign was in between, then we would write it as the double angle. But we can't do that here. So what do? We apply something called the sign change rule. We take out a negative that allows us to basically swap cos squared x and sine squared x. Because remember, if I take out the negative, if I take the negative and distribute it back, what's negative times cos squared x? It's negative. What's negative times a negative sine squared x? I get back the positive. So we apply the sign change rule, and then the answer can be written as negative. This is the double angle of cos, so this is negative cos 2x. Done. Finito. All right. So, guys, our reduction just needs to be on point. We need to just be on point, So that's why now we need to be reminded of that thing of, okay, for co-ratios, what is the rule? For angles that are negative, what do? For angles that are greater than 360, what do? Because all of that will help us in being able to simplify this thing. But if we have forgotten the fundamental basics of what do we do for certain function values, then that's where the danger is going to be. And then the failure from your side to put things in brackets, because sometimes signs, guys, are the signs are the nemesis. The signs are they are the devil that usually gets people to not do things correctly. Okay. Yes, it is. The thing is, clutch picks much of what the grade 12s do. Remember, mathematics for grade 11 and 12, 75% of the maths that is done in grade 12 is grade 11 work. So if you don't do the heavy lifting in grade 11 and you are careless, then you are going to see how your grade 12 will basically take on the same tone of what you were doing in the previous grade. Okay. Right, let's look at, so that was all multiplication. Let's look at some simplification questions where there is division in the mix. Okay, so sine of negative alpha times cos of 180 minus alpha minus cos of 360 plus alpha times sine of 180 degrees plus. They are very sensitive bongos, you can say that again. I don't know if people actually know how sensitive the signs are. So it's sine of negative alpha times cos of 180 minus alpha minus cos of 360 plus alpha times sine of 180 degrees plus alpha. That's all over cos squared 180 degrees minus alpha plus cos squared 90 degrees minus alpha. Okay, now that might look like a complex problem, but it isn't, guys. You can see evaluate minus sign, evaluate division line, evaluate, plus sign, evaluate. Okay, so there's nothing in this thing, like we just need to be skilled at doing what we know we ought to do. So first and foremost, let's look if everyone is fine. So first and foremost, this is a negative angle, sine of negative alpha. Okay, yeah. Now we add 360, we know that this is going to be in the fourth quadrant. So how is sine in the fourth quadrant? Okay, but remember guys, like I said, calculator can help you. You just take sine, you substitute 1 degrees there in this place, you will see what the sine is. Sine of negative 1 degrees, you say equal, you're going to see, oh, the sine is what? Okay, you'll get a numerical value, but the sign for the entire trig ratio is actually going to be a negative sign. So that's why you say this is a negative sine of alpha. And I put brackets. I insist on brackets, especially when there's a multiply. Okay. Then you evaluate cos of 180 minus alpha. Cos of 180 minus alpha, 180 minus is in the second quadrant. How is cos? Cos is negative. But remember, if you don't want to think too much about the quadrants, you take 1 degrees, you substitute here, you put in your calculator cos of 180 minus 1. So cos of 179, you'll get a what? A negative answer. So that means cos is what? Is negative. Okay. Yeah, if you really want to, not think about this quadrant stuff, you can do that. Substitute 1 degrees, say 180 minus 1, you get 179. You cos of 179, you get a negative answer. That means that cos is supposed to be negative. Okay. The minus sign follows. We evaluate cos of 360 plus alpha. Remember, this is a 360 plus. This means we are greater than 360. We subtract 360. When we subtract 360, we have 0 plus alpha. That basically means that cos is alpha. It just is cos alpha. Okay. Then last but not least, sine of 180 plus alpha. Okay, you can do the same thing. Substitute 1, you'll get the sine. But we know that 180 plus is in the third quadrant. How is sine? Sine is negative. So we have negative sine of alpha. If you substitute the 1, you will see the negative value, which means the sine trig ratio is negative. Okay. So far, good. 1, 2, 3, 4 marks collected so far. Yeah, and you guys think marks, it's easy, guys, these marks. Now, very careful here, guys. Very careful. Okay. Let us not forget that whenever we have a square, okay, I just want you to see on the side, this is like we need to first say cos 180 minus alpha. That square needs to be outside first. The square needs to be taken outside because the square applies to the trig ratio. It applies to just the trig ratio, guys. So you evaluate what cos 180 minus alpha is. That is obviously going to be negative cos alpha. But then when you square that negative cos alpha, what do you get? You get a positive cos squared alpha. So this here square, the even exponent, will always produce a what? A positive answer. Always, guys. Always. That's why, for instance, when you guys look at past question papers, I know some of you do that a lot. You look at the memo and then you have something like this. Okay. Usually what you will see in the memo is you will see they don't even show you what happened. But all of a sudden what you see is you see cos squared alpha written after this particular function value. Why? Because it is intuitively known that whenever there is a square for a trig ratio, the result will be positive. Okay? So if you move from here to that, you will get all your marks, guys. You will not lose anything. All right? So So, but you need to understand that the steps that basically led to the positive cos squared alpha was simply the fact that you take out the exponent 2, you evaluate the function value, you do get a negative cos alpha, but then after you apply the square to the entire trig ratio, you get a positive outcome, because an even exponent affects the negative sign by changing it from negative to positive. And why do you ask? It's because, remember, a square is simply saying -1 times another -1. In other words, a negative times a negative, and we know that a negative times a negative is positive. All even exponents, guys, applied to a negative sign lead to a positive outcome. All even exponents, as long as the exponent is external to a bracket that has a negative inside, the result will be positive. Okay, I don't know what's happening here. Something is happening. Like, I sense that we will end if detected inactivity during your live. You see, TikTok, please don't do funky stuff. I'm only teaching a math lesson. I am not doing any funky stuff. Isha, these guys are delaying me now. There's some pop-up that has happened here, but okay. So once again, now let's move on. The next thing that we need to do here, all right, fifths, I think fifths, what you can do is you go and subscribe to my YouTube channel, will you? Like, the link is in my bio. I will upload this lesson so that you can rewatch it yourself. Like, all the lessons that I do in the morning, I upload onto the YouTube channel that I have. The YouTube channel is called Maths is a Game 5 to 7. But what you can do is you can go to my bio. There's 2 links there. There's the link for the WhatsApp channel, not the WhatsApp channel. The WhatsApp channel is not used. It's underused. Go to my YouTube link. You click on that link, go to the channel, subscribe, and then you can actually go ahead and check that out. Okay. Tohu, alpha is not 1. Remember, alpha is not 1. All I said to you, remember, these angles that you have here are acute angles. Okay, so all I am saying to you, if you don't want to think about quadrants and all of that stuff, you can substitute 1 degrees in your calculator. Then you can punch this thing in your calculator, and then the answer that you get, okay, is going to be a negative answer. You're going to get a value, but you're going to see it's a negative value. That helps you to be able to write the sign for your trig ratio. Same thing with cos 180 minus alpha. If you don't want to use the whole thinking of the quadrants, where is cos positive and so forth, you can just substitute 1 degrees in the place of alpha because it's acute. This is just a random value. You could substitute any other acute angle if you want. Okay, you substitute that, then you punch it into your calculator, then the outcome you get is negative. You get a negative value, which means cos is negative. Okay, I'm just trying to help those who may feel like this whole thinking of which quadrant, say I don't get the signs correct, I usually forget, I mess up. So what you can simply do for yourself is substitute a random acute angle. Like, for instance, 1 is acute. You substitute that, you punch this into your calculator, the answer you get is negative, so that means the sign for the trig ratio is negative. Okay, it's not that alpha is 1. Please, guys, I'm just utilizing that as an example for people that don't want to think about this whole quadrant thing. Okay, now let's finish up this thing. Cos squared 90 minus alpha. So here again, 90 minus, that's your co-ratio. That means the trig ratio cos is going to change to sine. Okay, but however you evaluate this, it's going to lead to a positive answer anyways. So I'm going to not waste time. I'm going to write sine squared alpha. That is basically my evaluation of cos squared 90 minus alpha. Okay, I hope it makes sense, guys. And guys, these are all marks 1, 2, 3, 4, 5, 6, because I reduced correctly. And guys who don't want marks, they will mess up sign somewhere there, and it's gonna be a mess. And guys, you don't have to. Why do you have to do that? Don't sabotage yourself. Now, since I put all these in brackets, I can now resolve the signs. Negative times a negative, that's positive. So I know this is sine alpha cos alpha. The bracket has been removed. I know the relationship is multiply. Negative times a positive times a negative. What's a negative times a positive? It's negative. What's a negative times a negative? It's positive. So that sign is positive. I remove the brackets now. Cos alpha, sine alpha. Then, what's cos squared alpha plus sine squared alpha? Grade 11 syllabus. This is your identity. Okay? Addition is commutative. This is like saying sine squared alpha plus cos squared alpha. That's equal to 1. Very good, no zipo. Okay? And those are marks, guys. In the denominator, 1 is not significant, so I can actually, I know even if I don't write it down, it's there. Now let's evaluate this. What's sine squared alpha cos alpha plus cos squared alpha sine alpha? That is our compound angle. In actual fact, those who say it's a compound will say it's sine alpha plus alpha in brackets, and then they will get sine 2 alpha. Some of you will see like terms, sine alpha cos alpha plus cos alpha sine alpha. Those are like terms. So some of you will say sine 2 alpha cos alpha, and then they will write the answer sine 2 alpha. Remember, these are like terms. Okay, so that's one way of doing it. Some of you will not see it that way. You will see it this way, and then you'll write your answer as sine 2 alpha. Okay, whatever floats your boat, guys, as long as it is correct, the steps, we are 100% fine. Now imagine how many marks you get. 1, 2, 3, 4, 5, 6, 7 for simplification. 7 for simplification. 8. And they say trick. Hi guys, collection. Let's just collect these marks. Don't leave anything to waste. Don't waste marks, guys. Don't waste marks. Don't waste marks. Easy marks, easy capizzi marks. I don't waste marks, guys. Papa. Where did the course go? Which course are you talking about? No, Zipopagati. Which course are you talking about? You're asking where did the course go? I'm wondering what course are you talking about? Are you talking about cos squared 90 minus alpha? Are you asking where did the cos go? 90 minus is your co-ratio. What did we say about your co-ratio, guys? We said that when we have a co-ratio, 90 minus, 90 plus, 270 minus, 270 plus. Those are our co-ratios. Cos changes to sine. If this was sine, sine would change to cos. Okay? Yeah. So you need to be sensitive, guys. Yourselves, you need to be sensitive to the type of function value you have. This is a co-function value. It leads to a change in trig ratio. So if you don't know that, it's going to be the one thing that is going to stand in the way of your success. Remember, if you're not sensitive to that, you would have still retained this as cos. And then you would have said this is 2 cos squared alpha plus cos squared alpha is 2 cos squared alpha in the denominator. And then that would have been it would have been a really, really painful experience for you to actually make. You see? So I hope you understand now where the cos went. Cloni? Hi, my leader. I wake up at 5 and start the lesson. So awkward time indeed. But you see, the thing is, I don't have time. I'm a teacher myself. I have to get ready for school myself. I need to be leaving very soon. Okay? In the next 5 minutes, I need to be going myself. So I'm sorry, it's just that I don't have time. My evenings, my afternoons are dedicated to my own learners. Time is tough and time is very tight. So very sorry for you. But I do upload all the lessons onto my YouTube channel, so you can rewatch them at your own time, at a time that's convenient for you. So I'll be uploading what I did here. Okay, hopefully you can have mercy, forgive me. Okay, I'm just gonna do one last one, guys, before I leave. Cos 90 minus 2x. Okay, 2 minus 2 sine of negative x. No, I don't, because like I said, guys, my time, okay, every morning, guys, I'm live every morning at 5, unfortunately. So if you're not an early riser, you know what they say, the early bird catches the worm. Yes, I'm an early bird, catch that worm early in the morning. Okay, I'm doing this one because I just want to sort of like, I think, who's this? Sorry. Zippo Pagati needs to be very much sensitive to the 90 minus and what happens with them. Okay, so once again, in the numerator, we only have that one. It's cos 90 minus 2x, so we can evaluate that. There's 2, that's minus, that's 2, that's sine of negative x, that's a negative angle, we need to evaluate that. And then we have times cos of 90 plus x, we need to evaluate that function value again. Okay, so cos 90 minus 2x, let's evaluate that. 90 minus, that's our co-ratio, so cos changes to, please guys, sine. Then we have sine of 2x. 90 minus is in the first quadrant. How is cos in the first quadrant? It is positive. So therefore it's sine 2x in the numerator. Mark. Got a mark? 2 minus. Now we need to evaluate sine of negative x. Sine of negative x, guys, when you evaluate it, I'm going to put it in brackets. Sine of negative x is equal to what? Remember, we add 360, so that becomes 360 minus. It's in which quadrant? It's in the fourth. How is sine? Sine in the fourth quadrant is negative. So we have sine x. Remember, you could do the substitution of 1, guys, and you would still get the sine. Okay? Just saying it for those people that basically don't want to think about quadrants. Then we're going to evaluate 90 plus x. 90 plus is in which quadrant? It's in the second quadrant. How is cos? Cos is negative. But remember, since it's 90 plus the co-ratio, that means cos changes to sine. I hope Nozippo is with me and can see. Nozippo is not asking, what happened to the cos? What happened to the cos? Yeah, Nozippo. I hope you're not asking that question now. It's clarified in your head. You are clarified. Okay. Okay. Hopefully you are clarified, Nozippo, because it's important to be clarified. Once you are clarified, you are fine. Okay. And then, like I said, to those people that don't want to think about quadrants, what you can simply do, you just put 1 in the place of x. Take your calculator, say cos 90 plus 1. It's cos 91. You say equal in your calculator. The answer you will get is a decimal, but it will be negative. So that means the sign for this one is negative. But since you are working with 90 plus, don't forget that cos changes to sine. Please, guys, if you are feeling lazy about doing this whole quadrant thing, then substitute 1 in your calculator. It's same thing here. You could say sine of negative x. You take in the place of x, you substitute 1. You say sine of negative 1. You press equal in your calculator. Your calculator will give you a negative answer. That means the answer is negative sine x. If you don't want to think, there is your way out. Okay. Now, sine 2x, this is a double angle. All right. But before we jump into converting that to a double angle, let's go first and resolve what's happening there downstairs. We have 2 minus, minus, minus. Okay. And what we want to do then with 2 minus, minus is we basically want to resolve what the sign combination is down there. Okay. So let us resolve it very quickly as well. So negative times a negative times a negative, that will give us a, so we have 2 there, that's negative 2 sine squared x. Okay, I hope you can see that. 2 minus 2 sine squared x, because a negative times a negative times a negative gives you a negative, guys. Okay, and that's all multiplication. All right, then I'm not done. Sine 2x must just hang tight. Hang on, my little sine 2x. Just hang tight. Okay, now I'm sure you guys can see here that we have 2 minus 2 sine x. There's a highest common factor there. I have 1 minus sine squared x. Okay, and then I can see that this 1 minus sine squared x, okay, we can utilize in this 1 minus sine squared x in the bottom. This here is sine 2 sine x cos x. Okay, but then in the bottom, remember 1 minus sine squared x actually gives you what? Cos squared x. This here, guys, is that identity. You know, sine squared x plus cos squared x gives you 1. But if you make sine squared x the subject, that actually gives you 1 minus cos squared x. Or if you use the subject being cos squared x, that gives you 1 minus sine squared x. Okay, these are grade 11 identities. We ought not to forget them as well, because as we are in grade 12, these identities, they still hold. Sine squared x plus cos squared x gives you 1. Okay, so in my head, as I took out the common factor there, 1 minus sine squared x. Okay. Okay, so once again, you see, Tohu is asking that question that I've been explaining. No, clutch picks. No, that's not the way. Sine 2x remains as sine 2x. You can't say this is 2x sine x. No. It's not 2x sine. No. Clutch picks. Remember, this 2x refers to the angle of the trig ratio sine. So you can't write it as 2x sine. No. Okay, please. That's a danger. That is very dangerous to actually think, because this is a trig ratio followed by an angle. So you can't write the angle before the trig ratio. The angle always follows the trig ratio. Okay, so this is sine 2x, but it is the double angle. The double angle expression of sine 2x is 2 sine x cos x. 1 minus sine squared x can be written as cos squared x. Where did I get that from? That's from the identity. Okay, remember, sine squared x plus cos squared x is equal to 1. If I make sine squared x the subject, take cos squared x over, it's 1 minus cos squared x. If I make cos squared x the subject, I take the sine squared x over, I change the sign, I have 1 minus sine squared x. So I've just substituted 1 minus sine squared x and I've written cos squared x. The relationship at the top is multiply. The relationship at the bottom is also multiply. Cancellation can happen. So who goes? The 2 and the 2 cancel. The cos squared x and the cos. I cancel one of the cos's at the bottom. This here I'm left with the number 1, but here I'm left with one of the cos x's. So what is the final leftover stuff at the top? It means I have sine x. At the bottom, I'm left with a cos x, but this is the what? The identity. Sine x over cos x from grade 11. The identity sine x over cos x can be written to be tan x, the quotient identity. So guys, tan x is equal to sine x over cos x. This is the grade 11 identity that you learned, the quotient identity. This here was the square identity that you learned in grade 11. You see, so these things from previous grades are still applied. The only time I used grade 12 here in this problem was here in this step. Sine 2x, I wrote it as the double angle expression. Everything else that I applied was all grade 11. I don't know if you are hearing me and you are hearing me well. So that's why I'm saying to you guys that the grade 11 stuff, you need to also be on your game when it comes to them. You can't say that grade 11 is in the past, I am now in grade 12. You must still know your strategies and also your application of trigonometry for the grade 11 syllabus that you learned. Guys, I now unfortunately have to end the live. You cannot say cos x over sin x is equal to... No. The identity says tan x is equal to sin x over cos x. Okay. User, if you are going to say cos x over sin x is equal to tan x, then you are basically saying something that is not the identity. Okay. I'd hate to use a raw example. If you have told me that my name is Lucindi, so I love chocolates, and I'm allergic to peanuts, then I come to you and I'm like, well, Lucindi, so even though you are Lucindi, so here is a chocolate with peanuts. Then it just means because you gave me certain pieces of information. That piece of information is relevant because maybe if you are allergic to peanuts, you may die, if you know what I mean. So I can't come to Lucindy's of buying chocolate with peanuts. I have to buy, maybe you love chocolate, but you are allergic to peanuts. So maybe the right chocolate for you would be the chocolate that does not have peanuts, right? Because that informs a certain aspect of your identity, So it's the same thing with the square identity. Tan x is equal to sin x over cos x. It can't be something else. So if you come here and you say tan x is equal to cos x over sin x, you are killing yourself. That's like me saying that, Lucindy, so you need to eat the chocolate with peanuts, because I love you so much, Lucindy, so here's some chocolate with peanuts, Yeah, that just means I'm uninformed and I don't care. So please care, guys. Tan x is equal to sin x over cos x. It can't be tan x is equal to cos x over sin x, right? Please. So hopefully that problem, we can see how that developed. And guys, like I said, I have to end the live right here because I need to myself scooter baba, leave, go to work. Thank you so much for joining in. If you want to see me again, we'll see each other tomorrow morning, same time, same place, 5 a.m. guys, very early in the morning. We'll pick up from where we left off and we will do more simplification type questions. We'll go into numerical type questions and then hopefully we can also do identities. Okay, taking it one step at a time, getting through the trig, and thank you so much again. Also, like I said, I do have a YouTube channel. The YouTube channel is where I upload all these live lessons. So I'll just upload the live lesson as raw as you see it. So yes, please go watch it at your own time. Fast forward through the junk, especially when I speak a lot because it happens a lot. Fast forward through the junk and then, just go and get the emphasis on the things that I explained and re-explained again. Maybe there are things that you are really not vigilant and careful about. Those things that you are not vigilant and careful about, you need to become extra vigilant and careful about so that when you do the maths, it can flow for you too. Okay. Cheers, guys. Thank you so much. It was good. YouTube channel. You can go to my bio. Okay. I posted on my YouTube channel. Go to my bio. There's a link. There's a YouTube link that's there. You click on the link. It will send you to my YouTube channel, not the WhatsApp channel. There's a WhatsApp channel link as well on my bio, not that one. You go to my YouTube link on my bio. Name of the YouTube channel is called Maths is a Game. Maths is a Game. And I think it has a underscore thing, 527. Maybe you might be asking why Maths is a Game, because I believe Maths is a game. The more you play it more often, it becomes easy, but you must play it. You must play it. Remember, what you've just witnessed is me playing the maths. I am good. I am the one that knows how to do this. When you follow along, you are like, oh, I get what Sir is doing. But now you need to put yourself to the test. You need to go and find what are problems. You need to practice those problems. You need to also play the game. The more you play the game, the more familiar you become with the rules, the more you actually re-emphasize these things that are little, and the more you see those things and you do them yourself, okay, then the actual real learning takes place. And that's where you actually master the concept for yourself. Then level 5 to 7 becomes a possibility. Okay, I don't teach me for anything less than level 5 when I teach kids. So you must, level 5 to 7, guys, that's basically that's the region of performance that is acceptable, that shows that actual learning is taking place and actual mastery is happening with learners. If you are getting less than this, guys, then that means you are playing, to be honest. I'm not going to be mincing words. And the competition is very tight for grade 12s. The minute you are done, the minute you are done, you're doing ASC, I see, AKL, VPS, okay. But the minute you are done with grade 12 and you want to apply for your university courses and so forth, and you have a weak level for mathematics, it puts you at a disadvantage. Puts you at a great disadvantage. So we need to perform. We need to really perform. We need to give our utmost best. Okay. Yeah. Okay, so please, that's the link. That is the name of the channel. Maths is a Game 5 to 7. But like I said, the link is in my bio. You can click on that. Go on there. Please subscribe, and then you can make sure that when you actually have subscribed, you can actually, Doho, I don't know why you can't find it, because the link is in my bio. I don't know how you can't find it. It's there. The YouTube link is there. If you go to my bio, the link is there. You just click on the link. It will send you to the channel. And then all the lessons that I've done previously are also there. As long as they are, or as 1 hour long as they are there. Okay, guys, I need to love and leave you. Cheers. Have a good day. I don't know then, Doho. I really don't know.